Welcome to CSE's group, guys. Let us see 2014 circuit theory problems from UPSC CSE mains optional 1 electrical engineering. Question number 1 is determine E and I in the circuit shown here. Okay, so this is what the unknown voltage E and this is the unknown current I. In the question it is given that this AB branch is having 2 amperes current. Okay, so what we will do, we will merge this branch and this branch because these two are in parallel. Hence the voltage across 4 and voltage across 2 both will be same, and voltage across 4 can be easily identified as VAB is equals to 8. Okay, so that I have already written. This is VAB is equals to 8. So 4 ohms also is having 8 volts drop and 2 ohm is also having 8 volts drop, right? So if you merge 4 and 2, you will get 4 by 3. So your equivalent circuit will look like this. This is what the area which we had operated now. Okay, now you can apply the simple Ohm's law to determine the current which is flowing in this loop. Okay, so if I am considering the loop current is I1, then simply by using V is equals to IR relationship, you can determine the current which is flowing in this 8 volts branch or 4 by 3 ohms branch. So that is equals to 8 divided by 4 by 3, that is 6. Okay, now let us write the loop equation for the first loop or the left hand side loop, which is here, which is equals to E is 2 into I, which is here, plus 6 into I minus I1. Okay, because this 6 is shared between these two loops. Hence, you will get E is equals to 8I minus 6I1. Okay, so let's call this equation number 1. Now go to the second loop. Second loop equation comes out to be 8I1 minus 6 is equals to minus 8. Okay, so you have I1 with you. You have already determined that, which is 6 amperes. We can substitute this I1 value in this equation. Okay, and you will get current I. So if you do so, you will get I value is 28 by 3. So this is what the current which is flowing in the other loop, or the current which is required to determine. Next, take this current I and substitute in this equation. So if you substitute, so you will find, okay, yeah, if you take this I current and substitute in this equation, okay, so you will get E is equals to 116 by 3. Hence the voltage battery current which will be flowing because of that in the circuit is 28 by 3. The next question is question number 3. The Z parameters of a two-port network are here, and determine the Y and ABCD parameters. So please understand, you need to find out Y and ABCD parameter using Z parameters. So before that, guys, you need to understand how to convert Z parameter into Y and ABCD and Z parameter into ABCD. So let us start with Y. I am writing here the standard equation for Z parameters, that is V1 is Z11 I1 plus Z12 I2 and V2 is Z21 I1 plus Z22 I2. Okay, and Y parameters are given by I1 is equals to Y11 V1 plus Y12 V2 and I2 is equals to Y21 V1 plus Y22 V2. Okay, so you can do the calculation which I have shown here. What I am doing is I am identifying I2 from the equation number 2. Okay, that is this equation, and substituting it in the equation number 1. Okay, so if you do so, if you are substituting here, what will happen? You will be able to see V1 is Z11 times I1 plus Z12 divided by Z22 into V2 minus Z12 21 divided by Z22 into I1. Okay, so if you rearrange, you will find this big equation. Okay, so this is what the general method of identifying that. But look at here in the question, this derivation is not asked. So what you can do, you can simply use the relationship that impedance and admittance are inverse of each other. Hence, the Z parameter is equals to inverse of Y parameters. Okay, and the vice versa. So what is the meaning? You need to write the Z parameters in the matrix form and Y parameters also in the matrix form, and from there you can determine the Z in terms of Y as well as Y in terms of Z. You will be getting the same answer. Okay, so that is a quite easy solution for this one if you don't like this. So please remember this relationship, guys. Impedance is always inversely proportional to or is inverse of admittance. Hence you can always write Y is inverse of Z, okay, in the matrix form. So just write y11, y12, 21 and 22, the standard matrix notation, and for Z also in the same way, and just do the inversion. You will get these type of equations. Okay, so once you are having y11, 12, 21 and 22, just substitute that the Z values in that one, which I have done here, and you will be ending up with the answers which is required here. Okay, so y11 is 0.06, 12 is minus 0.02, 21 is minus 0.02, and 22 is 0.04. Okay, next is determine the ABCD parameter. Now ABCD parameter, such kind of relationship does not exist, so you need to derive if you don't remember that. So let us see how we can do this. Let us write the Z parameter first. Okay, Z parameter is here, the same thing, and ABCD parameter is V1 is A into V2 minus B into I2, and I1 is C into V2 minus D into I2. So the easiest way is to understand in this way. A, B, C, D you just write in the matrix form. Okay, so this is B. Okay, let me, yeah, this is B, and this is D, this is C. And what you need to do is you consider this in the matrix. Okay, if you don't remember what is the relationship for ABCD, and then write V2 here and minus of I2 here, close the matrix, and in the left hand side you write this is equals to V1 and I1. Okay, so by this you can always remember the ABCD. So how to remember that? Just write ABCD in the standard form. Okay, in the matrix, left hand side start with V1 and I1 because left side your port number 1 is there, and the right hand side of your two port network is generally considered as the second port, hence V2 and I2 associated with that. The only thing which you need to understand or remember is you are having a negative sign there. That is why in the equations also you are getting this negative sign. Now once you are having these two equations, it's very easy to write A in terms of Z, B in terms of Z, C in terms of Z, and D in terms of Z, right? So just this is linear algebra, just 4 equations are there, out of which you need to find out the relationship. Okay, so I've already derived these things for you. Please go through these equations. Okay, I don't want to spell all these. You need to go through it once and then substitute the values of Z, and you will get the ABCD values. Okay, so that is A is equals to 2, B is equals to 50, C is equals to 0.1, and D is equals to 3. Okay, so that's it. Now question number 4b is obtains the Norton equivalent circuit of terminal AB for the network shown below. Okay, so what I am doing here, I am solving it by two methods. The first method is I am determining the voltage VAB. Okay, this is A and that's B. Please understand, you need not to remove this 10 ohm. They are not considering that as a load resistance here. Okay, so they have already extended that terminals. That means they have already removed the load. Okay, so if you are determining the Thevenin equivalent of the circuit, then you need to do I1 and I2 and find out the voltage drop across 10 ohm. So I am writing here I1 equation is 100 is equals to 11 I1 minus 10 I2, and I2, the second loop equation is 20 is equals to minus 10 I1 plus 22 I2. Okay, so these two linear equation, two equations, two unknown, you can easily identify I1 I2 values. The I1 value comes out to be 16.9 guys, and I2 value comes out to be 8.6. okay, and VAB is the drop across this 10. So just multiply your I2 with the 10, which is equals to 86 volts. Okay, so this is what the current with voltage across the 10 ohm resistance, and the short circuit resistance can be easily identified by removing this voltage with a short circuit, this voltage by a short circuit. Okay, so equivalent circuit will look like this, and you can easily identify the equivalent resistance for this circuit. Okay, so this 1 and 10 are in parallels, that I am writing here, plus in series with 2 ohms, which is here, in parallel with 10. Okay, so whatever comes is the equivalent resistance, that is 160 divided by 71. Okay guys, then the Norton equivalent current is VAB divided by RTH, okay, which is equals to 86 divided by 160 by 71, which is 38.162. Okay, so that is the Norton current, and the resistance, the Thevenin resistance and the Norton resistance are same. So this is what the equivalent model for that. Okay, the other method is simply following the Norton step. So what you need to do is, let me remove these notations. Okay, that's it. Yeah, so as for Norton, you need to short circuit the terminals. Okay, and this current is your Norton current. So once you short circuit it, this 10 ohm will vanish. So this is no more. And then you need to apply simply the loop equations. Yeah, please let me remove this also, short circuit. Yeah guys, this voltage is intact. Yes, now you need to apply the simple loop equations. This is loop number 1 and that's loop number 2. So let us write these two equations. You will be getting these two, equation number 1 and equation number 2. Again, two unknowns, two linear equations. You can easily identify the unknown values, which is I1 and I2, 43.75 and 38.1 respectively. Okay, so Norton current is there with you. RTH we have already identified, or RTN we have already identified. Just form the equivalent network. Okay, so which is here. Thank you guys, that's it for 2014. Next we will be going for 2015 questions of UPSC CSE mains electrical engineering optional. Please comment about the video. Thank you.